All right, example 4. Solve x over x minus 3 equals 9 over x minus 3 minus 5. This is a rational equation. Just to have fractions in the equation doesn't make it rational. The fact that x's are in the denominator, that's what makes it a rational equation. Right? When x is in the denominator, that x as being a variable means the denominator could possibly equal 0 for certain values of x. We want to focus on that to begin with. So looking at this problem, before I make any modifications whatsoever to it, if x equals 3, I'm dividing by 0, right? Yep. So I have to make an initial statement before I begin that x is not allowed to equal 3. And I want to do that just in case I work all the way through this problem and end up with x equals 3 as an answer to the problem. I have to throw it out. Because the original problem has fractions in it. If x equals 3, we're dividing by 0. Division by 0 is a mathematically impossible thing. You're not allowed to do it. So we have to throw out that answer. So my goal here is to get rid of the fractions in the problem. And once I get rid of the fractions in the problem, that whole division by 0 is not there anymore. But the original problem had it, so I have to throw that out. So it's called an excluded value in case you're interested. So all I got to do at this point then is determine the least common denominator of all the fractions in the problem, which is basically just x minus 3, right? I'm going to multiply the entire equation times x minus 3. Dividing first, multiplying the result times the numerator. So x minus 3 divided by x minus 3 is 1 times x makes x. X minus 3 divided by x minus 3 makes 1 times 9 is 9. And this is not a fraction, so I'm going to get minus 5 times x minus 3. I would recommend writing it down like that before you distribute, especially here because there's a minus in front of the 5. Sometimes that minus sign is forgotten when you do the multiplication in your head. So you actually see it written there. It's a little bit more obvious. This is a negative 5 being distributed. So x equals 9 is still there. And then we get a minus 5x plus 15. Right? Then it's just a basic algebra problem at this point. We've got x's on both sides. So I'm going to take this negative 5x, move it over here. Keeping 9 and 15 on the right-hand side. X plus 5x makes 6x. 9 plus 15 makes 24. We divide both sides by 6. Gives me x equals 4, which is not my excluded value, which means I'm good to go. Let's say that I was doing a problem like this and I have an excluded value of x equals 3 and I end up with x equals 1, 2, and 3. Just take the 1 and the 2. Let's say I do this problem, I end up with x equals 3. Empty set. Okay, so that's what the excluded value does. It just says that's not allowed to be an answer. So if it happens to show up as an answer, toss it. If there's other answers, those are the answers. If there's only the one answer, empty set it. More often than not, it works out to just a number that isn't. I have to try really, really hard to get an excluded value show up on this. And I think I might have that happen on the quiz when it comes time. I think there might be an excluded value happening on the test quiz, but it's hard to make a problem where the excluded value ends up being the answer. So you have to really try hard.